Okay, all right, ladies and gentlemen, here we are with the second chapter, chapter 2 of Chem. We're looking at the classification of matter, and this chapter is broken down into two parts. One deals with energy, one deals with how do we classify matter. And we're going to deal with the first part, how do we classify matter. Now, the chapter 2 homework, again, that's going to be online. Just want you guys to pay attention. HChem, it's as above plus this as well. So let us begin. So matter is anything that has space, it occupies space and has mass. Okay, we covered that one in chapter 1. Now remember, between chapter 1 and chapter 2 we had 1.5 dealing with a lot of equipment, which is essential. But now we got to go back into Chem. Now, where did matter come from to begin with? Well, that's just it. The scientists who don't believe that God exists say it was a big bang and it just came about. But as Christians, we know that matter was created ex nihilo, which means Latin, out of nothing by God in Genesis 1. Okay? So when we look at the organization of matter, okay, there's two ways to look at it. There's mixtures and there are pure substances. Mixtures and pure substances. Now, how can we tell if a substance is pure or is it a mixture? Well, there's a couple of things we can look at. We can look at physical properties. We can also look at chemical properties. So we're going to look at physical properties first. One is we can measure without changing the material into another substance. So that's how we can look at physical properties. So examples would be color. Now, notice how each letter of the word color has a different color to it. Okay, except for the L and the C. Taste, texture. Is it smooth or is it rough? Okay. Physical state, is it a solid, a liquid, or gas? Those are all examples of physical properties. It's not all of it though, but it gives us an idea what can we know about the material. But there's also something called density. Now density is actually the ratio. We're comparing two numbers of the mass of a substance compared to its volume. So in density, we look at two things. We look at mass and we look at volume. That's what we're looking at. So our formula is density equals mass over volume. Mass divided by volume. The units typically will be grams per cubic centimeter or grams per milliliter, depending on what is being done. And we are going to do a density lab. Now, there's other physical properties that we can look at. We can look at malleability. How easily can a material be hammered into shapes? Think of so many metal objects that are out there. We can easily hammer them into shapes. Ductility. How easily can the material be stretched into a wire? Think like guitar strings. Okay? But we can also look at conductivity. How well, the ability, how well can it do it of a material to transfer heat or electricity between its particles? So we can look at electrons flowing through here from the negative end to the positive end. Okay, think about connecting for electricity. Okay, but wait. Particles? Well, what's that? Well, what are particles? This is a very important idea in chemistry for us. For particles, this is a term that we are going to use throughout the year. Particles are either atoms, molecules, or atoms and molecules together. That's what particles are. Now, so we looked at a number of things, the physical properties. Now we're going to look at chemical properties. Now there's two main ideas we've got here. One, how matter acts when other materials are combined together. Example, concrete with water equals hard substance. Perfect example. Here we are on the 210 freeway. Here's the overpass of near Azusa Avenue. See the cement there? That's concrete. Okay? We mix it with water and it's nice and hard. That's a chemical property. Okay? Because it wasn't like that before. The second thing is how material changes composition. Well, wait, what's composition? What is it made of? When enough energy is added to it. Example A, gasoline on fire. B, iron rusts. Those are also examples of chemical properties. How well do they respond? Some things don't catch on fire no matter how much energy you put to it. Others, it catches on fire way too easily. So we looked at physical chemical properties, we looked at chemical properties. We also need to look at physical and chemical changes as well. So a physical change is a change in physical properties. Okay, substance remains the same. You start with A, you end with A. Folding up a piece of paper, it's still paper. Light a piece of paper on fire with a match, now that's not a physical change anymore. Because I'm starting with paper, I'm going to end up with carbon. That's a chemical change. That's where we have a substance changes. A new substance formed, composed of different particles, start with A, end with B. Yes, that's how it works. So, physical and chemical changes, I do have a video that does cover that, and I do give some specific examples with it. So we've looked at physical properties, chemical properties, and then physical and chemical changes. But now let's get back to it. We said that matter was classified in one of two ways, pure substance or a mixture. Now, a pure substance consists of only one type of matter. That's it. Mixture is material that can be separated into two or more pure substances by physical changes. So when we look at mixtures, there's two kinds. We have heterogeneous, aka means also known as suspension. Ooh, I gotta change this a little bit. It's suspension, guys. Okay? And the parts settle out because of gravity. Hang on one second, I'm going to go change that right now. Sometimes. There we go. Boom. Okay, fixed it. Now, so we have two kinds of mixtures. We have pure substances and mixtures. We're going to look at mixtures right now. So we got two kinds. There's heterogeneous, also known as a suspension. The parts settle out because of gravity. Typically, your salad dressings are like that. They can settle out very easily with the gravity. We can see the parts. Homogeneous, aka solution, is a uniform mixture of two or more pure substances. We can look at something like milk, for example. That would be a pretty reasonable thing to look at. Now, we've looked at mixtures, heterogeneous, homogeneous mixtures. Now we're going to look at pure substances. Two types. One would be elements, the other are compounds. Now they can only be separated into other kinds of matter by a chemical change. So in other words, they got to be separated not by us tearing it apart, pulling it, folding it. No. We have to use chemical changes in order to do this, okay? So we have elements like silver. We also have compounds that is also a pure substance like water. And there's our molecule for the water. So an element, it's a pure substance. It can't be broken down into a simpler substance. And it's made up of only one kind of atom, like gold. Gold is an element. Oxygen is an element. Hydrogen's an element. Helium is an element. Iodine is an element. Einsteinium is an element. Rutherfordium. It's also an element. So is sodium and potassium and fluorine and mercury and calcium and phosphorus and nitrogen. They're all elements. But again, okay, we got that. What are atoms exactly? Well, the atoms are the particles that make up the elements. It is the smallest piece of an element, and we can still call it an element. Okay? Now, there are smaller particles than the atoms. They are made up of subatomic, that means smaller than atoms, particles. Protons, neutrons, and electrons. We cannot take a gold atom, break it, and I got a gold proton. No. A proton is a proton is a proton. A neutron is a neutron is a neutron. An electron is an electron is an electron. It doesn't matter if it comes from gold, silver, or platinum. It doesn't matter. Because at that point, all protons are the same. All neutrons are the same. All electrons are the same. That's how it works. Okay? All right. So when we have an atom that has a positive or a negative charge to it, that's what we call an ion. Now, we'll get into that later. This is just looking at the big overview of how we classify matter. Okay? Now, the thing is, every element has its own chemical symbol. It can be one or two letters. The first letter is always capitalized. Okay? It just is. And the second letter will always be a lowercase. So, for example, here, B is for boron. Not boring. Boron. Ca here is calcium. Notice that the A is a smaller case A, a lowercase a. Okay? Now, elements naturally occur in three categories. Well, what do you mean naturally occur? We find them in nature in either one of these possible states. It could be monatomic by themselves, like neon and argon and helium. Those tend to be the loners. They don't necessarily hook up with anybody else. They just don't. They're on their own doing their thing. Now, some are diatomic, like O2 and H2. Now, in nature, we'll find hydrogen hooked up with hydrogen, typically. Now, hydrogen can be hooked up with other things, yes, but normally, if we're looking at a pure substance, elements, okay, like O2 and H2, yeah, they hook up. That's typical. We find them that way. The other one is polyatomic. Poly meaning many, okay? Certainly more than two. So O3 and S8. So S8, that's 8 sulfur atoms hooked up. O3, 3 oxygen atoms hooked up. Well, wait, what's the difference between O2 and O3? Could we breathe in O3 and live because we get the extra oxygen? No. O3 is ozone. That protects us from the bad effects of the ultraviolet radiation from the sun. We kind of depend on that. Yeah, we do. Molecules. So, 2 or more atoms chemically bonded together. Okay? So, it could be atoms of the same element or different elements. So, here's an example of a molecule of caffeine, lifeblood of a number of people out there. Now, here is an example of molecules of air that we breathe in. And you may notice they could be the same atom, like we see here, or it could be different elements. Okay? Same element, different elements. And again, some of them, they're loners. Yeah. Compounds. So, compounds are molecules from 2 or more different elements that have been chemically bonded together. Okay? Pretty much like water. Water is an example of a compound. Okay? Now, formula tells the number of atoms of each element present. Okay? So, here's the thing. One of the big things in chemistry is we get to deal with formulas. Okay? And it's a way of telling people, all right, what elements are there, how many are there, okay? So a compound's chemical formula tells what type and how many atoms are present in one molecule of a compound. Example, Fe2O3. These are subscripts. I have 2 irons and 3 oxygens. This is one Fe2O3 compound. Now, this Fe2O3, I've guaranteed you've seen it before. You know it as rust. Boom. Chemistry. A subscript and a coefficient. Well, the subscript we already talked about. That's the number that indicates the amount of atoms or groups of atoms in a formula. This are subscripts. A coefficient is a number in front of a formula which tells how many molecules or atoms are present. Example 5Fe2O3. This 5 is our coefficient. So how many of these atoms do we have? Well, that means we have 5 times 2, 10 of these iron atoms, and then 5 times 3, 15 of these oxygen atoms together. Okay, so this is what we have. Because of that 5, we have got 10 iron atoms total, and 5 times 3, 15 oxygen atoms total. That's how we know. This is how we put things together. This makes sense. All right, moving on. And with that, ladies and gentlemen, we conclude Chapter 2A, Classification of Matter. You may have noticed we covered quite a bit. We looked at what was matter. We looked at how matter was classified in terms of there are pure substances and there are mixtures. We also looked at physical properties, chemical properties. What does that tell us about the compound or the atom or the element? Okay. We also got into things like physical change and chemical change. And then we started to talk about mixtures, homogeneous mixtures, heterogeneous mixtures. Then we started to look at atoms, elements, okay, and molecules and compounds. And then we started to take a little glimpse as far as chemical formulas themselves. And with that, ladies and gentlemen, I hope this benefited you. Goodbye and God bless. Take care.